Hello and welcome to Science and Sleep, where we both relax and explore the silent mysteries of the universe around us. Let the rain outside become a lullaby for the mind, and let me tell you about the tiny yet powerful chemical reactions that quietly paint the picture of life. Tonight, we will embark on the journey of the chemical reactions of rain, where each drop falling onto the roof, slipping through the window pane, and seeping into the earth opens up a miraculous story. If you find this journey exciting, don't forget to subscribe and stay until the end of the video, because perhaps you will never look at rain the same way again. High above the sky, where sunlight pierces through the thin layers of atmosphere, a silent process is happening every second. Water from the vast oceans, from rivers and streams, and even from dew-covered leaves gradually disappears from its liquid form to merge into the air. That disappearance is neither noisy nor easily seen, but it is the very first step in the journey of a raindrop. We call it evaporation. At first glance, evaporation seems to be just a simple phenomenon. Water turns into vapor and rises. But if you pause to observe, you will realize it is a process both delicate and powerful. Each water molecule is like a tiny dancer, always in constant motion. When they have enough energy, usually from the warmth of the sun, they can escape the embrace of other molecules to rush into the atmosphere, becoming water vapor. Even without the sun, like on a cool day, this process still quietly happens, only more slowly, more patiently. That means the atmosphere around us is always filled with invisible water molecules. They cannot be seen with the naked eye, but they create the humidity we feel on a sweltering day or the chill when fog blankets the path on an early morning. And the ocean itself, with its immense surface, is the lung that provides enormous moisture for the planet. An ocean can evaporate millions of tons of water in just one sunny day. If you take a deep breath right now, chances are some of those water molecules once caressed a wave in the Pacific Ocean just a few days ago. But water vapor alone cannot create rain. To turn into drops, water needs a place to cling to, a home to gather around. This is where a miraculous chapter begins: condensation. The air around us is never completely pure. It is full of tiny particles, like a bit of sea salt carried from breaking waves, a few grains of dust from distant deserts, ashes from forest fires, or even just pollen drifting from a flower field hundreds of kilometers away. These particles, seemingly trivial, are wonderful catalysts. They are called cloud condensation nuclei. When water vapor meets these tiny particles, the attraction between water molecules makes them cling tightly to each other. A thin film of liquid begins to form, wrapping around the tiny speck of dust. One molecule becomes two, then a cluster, and soon from an invisible particle in the air, a nascent droplet is born. Without these nuclei, rain might never fall. Pure air, paradoxically, does not encourage water to condense. So it is fascinating to think that dirt is actually the midwife of rain. What we often consider pollution sometimes forms the foundation for the rains that cool the earth. Without dust, water vapor would wander endlessly in the sky without ever clustering into drops. But when the conditions are right, temperature drops, pressure changes, those tiny droplets multiply by the billions, clinging together to weave a cloud. Imagine this: every cloud you see in the sky is in fact a floating city of countless droplets. Each drop is smaller than a strand of hair, but when billions exist together, they create a massive mass that shades the entire sky. Though soft looking like cotton, an average rain cloud can weigh thousands of tons, and all that weight is floating above us, held aloft only by the air currents. In that suspended state, rain does not yet exist. The tiny droplets are still dancing, colliding, merging, and sometimes evaporating back into vapor. It is a never-ending ball where every water molecule is trying to rearrange its destiny. Some join together and grow bigger. Others vanish and return moments later. This is the vitality of clouds, always changing, never fixed. Only when a droplet grows large enough does gravity begin to win. At that moment, the droplet becomes too heavy for the air currents to hold it back. And so the journey back to Earth begins. This is the moment a true raindrop is born. It is poetic to think that before touching the ground, a raindrop has gone through countless trials, escaping the ocean, rising into the sky, finding a speck of dust to cling to, then growing inside a cloud. It is like an adventure where each water molecule is a traveler and the atmosphere is an entire world of harsh conditions testing patience. And all these processes, evaporation, condensation, droplet formation, are silent chemical plays. No sound, no light, only the movement of invisible molecules. Yet their result is so clear that everyone has witnessed it. Rain falls, the earth is soaked, the scent of soil spreads, and life is replenished. So, when you stand under a heavy gray cloud, remember that above is not a lifeless cotton mass, but a gigantic laboratory where billions of reactions are happening at once to create something simple, a raindrop. And that journey has only just begun. One of the most fascinating truths about rain is that it rarely looks like the image we usually see in books or on signs. Think of the familiar blue teardrop shaped water symbol, a pointed tip and a rounded body. But in reality, nature does not follow those graceful lines. When it is still tiny, a real raindrop is a perfect sphere, held in shape by surface tension, the invisible force that makes water molecules cling to each other. But as it grows inside the cloud, the droplet begins to be pulled downward by gravity and pressed upward by air resistance, flattening it. Instead of being elegant like a teardrop, most raindrops look more like a slightly squashed hamburger bun, not romantic, but accurate. That truth is not just a joke of physics. The shape of a raindrop directly affects how we experience rain. A small round drop will fall gently and create a soft sound when it touches the ground. Larger, flatter drops strike harder and sound louder. Thus, the music of rain on a roof or the ground is in fact a geometric symphony, countless shapes colliding at different speeds, creating a unique rhythm for each rainfall. And rain does not only touch the ear, but also the nose. If there is an experience deeply tied to human memory, it is the smell of rain. The moment the first drops hit cracked, dry ground, the air suddenly becomes fresh, carrying a scent both sweet and earthy. People have given it a poetic name, petrichor. The word comes from petra, stone, and ichor, the mythical fluid flowing in the veins of the Greek gods. A name that evokes antiquity while expressing the almost sacred quality of this fragrance. But behind the romance lies a whole refined chemical story. During dry months, many plants release special oils that seep into the soil and cling to the surfaces of rocks. These molecules lie dormant, waiting until raindrops strike and release them into the air. At the same time, a group of soil bacteria, especially actinobacteria, also joins this symphony. When the soil becomes moist, they release a compound called geosmin, which carries the distinctive earthy smell of wet ground. The miracle is that humans are extremely sensitive to geosmin. Just a few parts per trillion in the air is enough for us to detect it. Perhaps in evolutionary history, the ability to sense the smell of damp earth once helped our ancestors locate fresh water, a precious survival skill. Not only that, the scent of rain is further enriched by ozone, the three-atom oxygen molecule, often produced when lightning tears through the sky. Storm winds bring ozone from high altitudes down to the ground, creating a sharp metallic smell. Thus, in every rainfall, we are inhaling a mixture of plant oils, bacterial breath, and even traces of lightning, a kind of natural perfume that no one invented yet has accompanied humanity throughout history. What is strange is that most of us love the smell of rain. It brings peace and comfort, sometimes awakening childhood memories, running through fields after a summer shower, or sitting under a roof listening to the gentle patter of rain. Psychologists believe this is the result of multisensory resonance. Cooler air, softer light, the soothing sound of rainfall, and petrichor all sending the brain signals of safety. Together they form a natural sedative. But rain is not only fragrance and memory. Hidden within each drop is an important chemical trait, acidity. We often think pure water has a pH of 7, neutral. Yet natural rain rarely reaches that level. Normally, rain has a pH of about 5.6, slightly acidic. Why? Because the air always contains carbon dioxide. When dissolved into a raindrop, CO2 forms dilute carbonic acid, making the rain a mildly acidic solution. This may seem small, but it has a large impact. A slightly acidic rain helps dissolve minerals in the soil, allowing plants to absorb nutrients. It also slowly erodes rocks, shaping landscapes over millions of years. In fact, such rains contributed to the formation of the vast limestone caves we see today. However, in the industrial age, humans have altered this natural balance. When SO2 and NO2 emissions from factories and vehicles dissolve into rain, they create sulfuric acid and nitric acid, lowering the pH much further. That is when we call it acid rain, a phenomenon that can kill forests, destroy freshwater ecosystems, and corrode architectural works. Thus, within each seemingly gentle drop of rain lies a warning. Shape, sound, scent, and even acidity all prove that a tiny raindrop is not trivial. It is the product of complex natural forces: surface tension, gravity, microbial life, lightning, and even human activity. Each drop is a delicate story of chemistry and physics, both familiar and mysterious. So, next time you hold out your hand to catch a raindrop, try to see it as a masterpiece. A tiny architecture where nature has skillfully balanced pull and push, clarity and gloom, nourishment and destruction. It not only dampens your shoulder, but also gently reminds you that science, in its purest form, is the art of the universe. When we think of rain, most of us often only picture its cool freshness, or sometimes the inconvenience of having to rush through sudden showers. But if we look deeper, each raindrop is in fact a tiny test tube, carrying within it a chain of subtle reactions invisible to the naked eye. It is here that chemistry and nature together write stories both familiar and magnificent. Imagine a summer rain pouring down after many sweltering days. At the moment the drops touch the ground, what you feel is not only relief, they are also messengers carrying nutrients and signals from the sky to the earth. Mixed in each raindrop are gas molecules that have gone through countless collisions, combinations, and restructurings on their journey from the upper atmosphere down to the ground. That is why the chemical composition of rain can reveal to us not only the condition of the air, but also the story of how nature and humanity are conversing with each other. One of the most astonishing moments is when a storm breaks out. Thunder and lightning are not only a dance of light and sound, but also tools for renewing life. With temperatures reaching tens of thousands of degrees Celsius, a lightning bolt breaks apart the strong nitrogen bonds in the atmosphere, something nearly impossible under normal conditions. In just a fraction of a second, nitrogen and oxygen atoms are released, then recombine into new compounds, forming nitrates, a wonderful natural fertilizer for the soil. And when rain falls, it seeps into the earth, joining the growth cycle of plants and nourishing entire ecosystems. It can be said that it is thanks to violent storms that forests grow greener and fields more fertile. Even our daily meals bear traces of this seemingly distant phenomenon. The proteins in rice grains, in vegetables, or in the bodies of all living beings are partly built from the fixed nitrogen that lightning has gifted. It is a miraculous balance between destruction and creation. The same lightning bolt that shakes the sky also sows the seeds of life. However, the chemical journey of rain does not always end positively. When gases released by humans intrude into this dance, the picture becomes more complicated and sometimes grim. During industrialization, coal-burning factories and smoke-belching vehicles contributed millions of tons of sulfur dioxide and nitrogen oxides into the atmosphere. When these molecules meet raindrops, they turn into sulfuric acid and nitric acid, compounds strong enough to lower rainwater's pH to harmful levels. And so instead of carrying nutrients, rain becomes acid rain, silently corroding forests, lakes, and even humanity's ancient cultural monuments. Picture European cities in the 19th century where the sky was tinted a dull gray, the air thick with smog, and rainstorms were more destructive than life-giving. Limestone from cathedrals, monuments, and intricate carvings was eroded in just a few decades. Ancient forests withered, fish vanished from lakes, and soil became depleted of nutrients. That disaster was a powerful warning that the chemistry of rain, if distorted by human influence, can become a double-edged sword. But thanks to science, we have also learned how to restore the balance. By the late 20th century, many countries strictly controlled emissions, adopted sulfur scrubbers, catalytic converters in cars, and moved toward cleaner energy. As a result, in many places, rain has become less acidic, forests have revived, and lakes have cleared again. This is vivid proof of the power of knowledge. Once we understand the chemical mechanisms, humans can find ways to reduce negative impacts and restore balance. On the other hand, not all rains are acidic. In regions rich in desert dust or limestone, rain may be slightly alkaline due to calcium carbonate carried by the wind. This type of rain, opposite to acid rain, can neutralize soil pH and add valuable minerals. This shows that each rainfall is unique, carrying the chemical imprint of the environment it passes through. By observing and analyzing, we can read an invisible recording of the atmosphere, of the actions of both nature and humanity. And perhaps the most thought provoking irony of this phenomenon is that rain, often associated with purity, is actually a mirror reflecting how clean or dirty the air is. From distant seas carrying salt spray to bustling cities filled with smog, each drop tells its own story. Sometimes it is a love song nurturing life, sometimes a warning about the cost of unsustainable growth. So, next time you sit by the window watching the rain fall, try to imagine that each drop is not just condensed vapor. It is the intersection of earth and sky, of nature and humanity, of creation and destruction. It reminds us that the world around us is more complex than we often think, and more importantly, it shows us humanity's responsibility to keep this chemical symphony harmonious, so that rain continues to be a source of life and does not become indictment against ourselves. When the rain quietly passes by, what remains is not only the wet ground or the shimmering puddles reflecting the lights. Behind that silence lies a complex painting of chemistry and physics drawn by nature. Each drop of rain is like a packaged memory, recording its journey from the atmosphere to the ground, from the moment it forms until it disappears. And if we are patient enough to listen, the rain can tell us untold stories about this world. One of the most beautiful stories is the rainbow, a phenomenon that may seem like a fleeting romantic moment, but is in fact the result of a series of strict physical laws. Each raindrop, when it meets sunlight, becomes millions of tiny prisms. They refract, reflect, and then refract the light once more, splitting pure white into a brilliant spectrum. The miracle here is that the rainbow you see actually exists only for you, because each position, each angle of view is a different combination of raindrops and light. The friend standing next to you may also admire that rainbow, but physically they are witnessing a completely different band of colors, woven from a different set of raindrops. Science calls this a personal optical phenomenon, while we often simply fall silent before its unbelievable beauty. And that beauty becomes even deeper when we know that it is created by the very rigid laws of light and water. What seems mystical turns out to be proof of the wonder in the way nature operates. Not only colors, rain also leaves behind a scent. The smell of rain, that sweet, moist feeling that everyone has inhaled, is actually a work of chemistry. Its origin comes from a compound called geosmin, released by soil bacteria. Normally, geosmin lies dormant in the earth, but when rain pours down, the droplets awaken it, releasing tiny molecules into the air. Blended with the scent of ozone created when lightning tears through the air, that smell evokes in humans a sense both familiar and fresh, a kind of olfactory memory tied to childhood, to wet summer days. More interestingly, the human ability to detect geosmin is extremely sensitive, with just a trace being enough for us to recognize it. That is precisely why the smell of rain has such a powerful emotional effect. If the rainbow is a gift for the eyes, then the smell of rain is a gift for the nose. Both remind us that chemistry is not just dry equations in textbooks, but vivid experiences rooted in memory and emotion. Beyond color and fragrance, rain also influences sound. Recall the moment when you sit in a small room, listening to raindrops tapping on the roof, the window, or even the ground. Those sounds are created by billions of collisions between droplets and material surfaces. Acoustics calls this natural white noise, a steady sound capable of soothing the nervous system, reducing stress, and bringing relaxation. Many music applications today recreate rain sounds to help people sleep better and concentrate better. But few remember that the original composition has been played by nature for millions of years. Rain does not only cleanse, does not only paint rainbows, does not only create scents and music. It is also a catalyst for much larger biological cycles. Many species are directly tied to the rhythm of rain. In tropical forests, rain is the signal for frogs to raise their chorus calling for mates. On the African savanna, rain triggers the breeding season of antelope herds, while awakening seeds that have lain dormant for months under dry soil. Even in harsh deserts, a brief shower can transform dead land into a vibrant carpet of flowers in just a few days. For humans, rain is also a part of culture and spirituality. In Eastern poetry, rain is often associated with longing and separation, but also as a symbol of rebirth. In many religions, rain is considered a gift from heaven, a blessing that nourishes crops. Rain rituals from ancient to modern times all reflect a shared desire to maintain the fragile balance between nature and humans. From a scientific perspective, rain is the inevitable result of the water cycle: evaporation, condensation, and return to the ground. But if we only look at it that way, we miss an entire treasure trove of meaning it carries. Each drop of rain is a connection between the atmosphere, the earth, living beings, and humans. It is a reminder that we are not separate from nature, but live within a complex system where every molecule has a role. More importantly, rain is also a mirror reflecting our actions. Its quality changes depending on the atmosphere humans create. When the air is clean, rain brings renewal. When polluted, it becomes acid rain, carrying harsh consequences. Therefore, understanding rain is also understanding how we treat this planet. The next time you look up and see a rainbow, or simply sit quietly listening to the rain fall, remember that you are witnessing an entire chemical symphony, a grand masterpiece that nature has orchestrated for billions of years. Behind that fragile beauty are countless reactions, cycles, and delicate balances. And within that balance, humans are not merely passive spectators, but a part of the performance. Perhaps the strangest thing about rain is the way it is both specific and universal. A shower in your backyard may seem like a small event, but in fact it reflects the planet's grand cycles. Looking more closely, we see each drop of rain falling like a page in Earth's diary, telling stories of climate, geology, and biology. Imagine a raindrop falling onto a rice field. Before touching the ground, it may have formed around a grain of Saharan dust, carrying with it phosphorus, a precious nutrient that the Amazon rainforest needs to sustain life. When it seeps into the soil, the raindrop blends that mineral into the fertile mud, nourishing the rice plant. The plant absorbs it, transforms it into grains of rice, and eventually, humans eat it and turn it into living energy. Just one raindrop, yet its journey links desert, rainforest, farmland, and humanity, an invisible network woven by chemistry. The astonishing thing is that this process never stops. When we eat that grain of rice, the water in our bodies continues its cycle. Part of it evaporates through breath, part escapes through sweat, and eventually returns to the sky. From there, it condenses into new raindrops, continuing the journey. Seen this way, each drop of rain is not just water, but a link in an endless chain of renewal, where life and chemistry intertwine. But rain is not only a messenger of minerals, it is also an artist, shaping the landscapes we live in. Mighty canyons, deep valleys, most are the result of millions of years of rainfall, erosion, and runoff. Tiny droplets, soft and fragile as they seem, over long periods can wear down rock and sculpt terrain. This is the soft power of water. Not loud, not hurried, but persistent enough to change the face of the planet. Not only does rain shape, it also heals. After devastating forest fires, the first rains are the soothing blanket that extinguish the ashes, wash away the smoke, and sow the seeds of new life. In crowded cities, a downpour can wash away layers of dust, revealing the clear blue sky again. Rain is therefore not merely a natural phenomenon, but the breathing rhythm of Earth's renewal. Yet rain also reflects the darker side of humanity. When the atmosphere is full of sulfur and nitrogen from industry, rain becomes acid rain, silently corroding forests and structures. When the air is thick with smog, rain carries pollutants into rivers and streams, altering ecological balance. The raindrop, once a symbol of purity, sometimes becomes a messenger bearing traces of negligence. And yet, even within these challenges, rain remains a connector. It forces us to recognize that the actions of one city, one nation can affect distant places. A smokestack in Europe can contribute to acid rain in North American forests. A wildfire in Australia can leave ash in the rains of South America. The sky has no borders, and so rain becomes a witness to global interconnectedness. This also reminds us that protecting rain, which means keeping the atmosphere clean, is not the responsibility of one land alone, but of all humanity. So that one day when we look up at the sky and see a rain shower, we can breathe in the scent of wet earth, admire the rainbow's colors, listen to the music of falling drops without fear of what they might carry. On a deeper level, rain awakens memory and emotion. Many of us have had special experiences with rain. The first time running through it with friends, the time sitting by a window watching the wet sky while our hearts were full of thoughts, or the night waking up to the steady rhythm of rainfall and feeling at peace. Such moments make rain part of our spiritual life, not just a physical phenomenon. Perhaps it is because rain holds within it unending cycles, from earth to sea to sky and back again, that humans have attached so many layers of meaning to it. It symbolizes renewal, new beginnings after storms. It symbolizes cleansing, the ability to wash away the past. And sometimes it symbolizes longing, for the sound of rain easily stirs sleeping memories. Science can tell us precisely how rain forms, what its chemical composition is, but science cannot measure the stirrings it awakens within each of us. That is the silent yet profound part of rain's chemistry. It dissolves not only dust, salt, or minerals, but also feelings and memories. And perhaps that is what makes rain so special. It is at once a meticulous scientist, transporting elements and regulating the water cycle, an artist, painting rainbows and composing the music of falling drops, and a philosopher, reminding us of fragility and connection. In every drop of rain, we see reflected both science and the human soul. Rain never arrives as a single event. It intertwines within the grand circulation of the planet and of life, being at once chemistry, energy transfer, and story. When a raindrop touches the earth, it not only quenches the land's thirst, but also initiates a chain of reactions that ripple throughout ecosystems, food webs, and ultimately reach us. Think of nitrogen, the invisible backbone of proteins and DNA. Though vital, most atmospheric nitrogen exists in inert form, unusable by plants. Yet storms with lightning split these molecules, creating nitrates dissolved in rainwater that seep into the soil. In this way, every thunderstorm becomes a planetary fertilizer factory, delivering nutrients to roots and fields without human hands. Thanks to this, crops blossom, forests thicken, and life is supplied with the raw material to continue, all originating from the silent service hidden in the chemistry of rain. Rain is also the great cleanser of the sky. Each drop, in its passage through the air, gathers dust, soot, pollen, and even microscopic organisms before reaching the ground. What seems like a simple shower is in fact a vast filtration process. Without it, the atmosphere would thicken with fine particles, horizons would blur, and the lungs of living beings would tire. The smell of soil after rain, the fragrance called petrichor, arises not only from damp earth but also from organic compounds released when raindrops stir the ground. One could say rain is nature's reset button, washing clean both sky and land so the cycle may begin anew. The dialogue between rain and plants runs deeper still. Scientists have discovered that raindrops themselves carry subtle signals that plants can read, almost like a language. When water touches leaves, it activates defense genes, preparing them to resist fungi that thrive in dampness. In other cases, the mechanical impact of raindrops triggers growth responses, prompting plants to strengthen stems or adjust leaf angles. Thus, every rainfall is not merely irrigation, but communication. Messages encoded in liquid between the atmosphere and living beings. The unique properties of water ensure this dialogue unfolds. Because hydrogen bonds allow water to dissolve so many substances, rain can carry an immense cargo of minerals and trace elements. Iron dust blown from deserts, salt lifted from oceans, even spores and tiny bacteria all ride along in raindrops. The rain falling into your garden today may contain echoes from half a world away, linking ecosystems across continents. In this way, rain is not only local nourishment, but also a global exchange, redistributing matter and microbes that sustain planetary balance. The influence of rain is also etched into culture and imagination. Ancient civilizations once saw storms as the voices of gods. In Mesopotamia, the god Adad was believed to hurl rain and lightning as instruments of fertility and power. In India, the monsoon was both blessing and trial, feeding crops while testing human endurance. Poets across centuries have found in rain symbols of renewal, melancholy, or transformation. Even today, the sound of rain against a window is enough to calm the mind, reminding us of our shared dependence on forces older than humanity itself. Rain touches memory because it has been present in every chapter of our collective story, from the first molecules of life to the earliest farmlands to the cities where we now endure. Climate change reminds us of the fragility of rain's rhythm. Though its cycle is eternal, its cadence can shift. Warmer air holds more vapor, making storms fiercer in some regions while others suffer scarcity. Farmers in drought stricken lands feel this distortion acutely as soil cracks and rivers dry. Elsewhere, sudden floods sweep away homes and fields. A process that once nourished and sustained life, when altered, can also sow destruction. Yet in this truth, we learn humility. Rain is not a resource to command, but a rhythm with which we must learn to live in harmony. To think of rain in its wholeness is to see chemistry at work, ecology in motion, and poetry patiently enduring. Every drop carries the memory of stars, the labor of storms, the nutrients of soil, and the breath of plants. It binds geology with biology, physics with spirit. And though we may describe it with the language of science, hydrogen bonds, nitrates, aerosols, its deeper meaning lies beyond formulae. Rain reminds us that the simplest substances can weave the most intricate stories. When you hold out your hand to catch a raindrop, see it both as a molecule and a messenger, a fleeting presence that carries within itself eternity. Rain on the ocean at first glance may seem unimportant, almost redundant, as if a few drops of fresh water could never change an endless expanse of blue. But upon closer observation, we realize that each raindrop is not just water, it is chemistry in motion, a messenger between sky and sea. The thin skin of the ocean, only a few millimeters on the surface, is one of the most dynamic interfaces on Earth. It is where light touches salty water, where gases escape or dissolve, where microorganisms thrive in vast numbers. When rain touches that fragile boundary, it does not disappear. It reshapes the chemistry of the surface, and with it the rhythm of the entire marine world. A rainfall creates a less salty layer on the surface. For plankton living there, this small change is decisive. Lower salinity affects buoyancy, nutrient uptake, even the rate of CO2 absorption. In nutrient-poor regions, such as tropical oceans, this temporary fresh layer acts like a nursery, keeping plankton in the sunlit zone where photosynthesis is most efficient. Just a few hours after rain, phytoplankton can bloom, covering the sea surface in a pale green that satellites in space can record. These microscopic plants not only release oxygen, but also feed zooplankton, young fish, and the entire marine food chain extending to whales. Rain is not just water, it is also a vehicle. As it falls through the atmosphere, raindrops collect dust, pollen, and volcanic ash, even drifting microorganisms. When they touch the sea, they bring iron, phosphorus, and other rare elements. In fact, massive algal blooms in the Southern Ocean have been triggered solely by iron-rich dust from distant continents carried by rain. Each storm is thus like a global delivery service, linking deserts to seas, volcanoes to algae, the atmosphere to the biosphere. But the chemistry of rain is not always gentle. Near cities or industrial zones, rain often carries SO2 and NO2, products of fuel combustion. When dissolved, they form acid rain, contributing to localized ocean acidification. Though the changes are small, plankton and corals feel them keenly. Growth and reproduction rates shift. This means rain also bears the imprint of humanity, reminding us that even the clouds are no longer pristine. Beyond delivering substances, rain stirs the sea. Heavy rain can break down water stratification, pulling nutrients from the depths to the surface. Fierce storms, often viewed by humans as destructive, are frequently golden opportunities for plankton. After tropical cyclones, oceans glow turquoise from space, a testament to life exploding in abundance. The influence of rain extends to larger creatures as well. Dolphins, whales, and seabirds do not drink seawater. They obtain water indirectly from food, which in turn depends on algae and plankton. When rain nurtures algae, the chain reaction rises. Small fish thrive, larger fish follow, seabirds multiply. A single rainfall can thus sustain an entire biological network, from microbes to killer whales. Although the freshwater layer lasts only a few hours before winds and currents erase it or before nutrients are quickly consumed, those brief pulses remain important. Because they repeat again and again, they form an endless dialogue between sky and sea. Seen from this perspective, rain is the bloodstream of Earth. It delivers nitrogen forged by lightning into plant roots, carries iron from deserts to oceans, links mountains to seas through rivers and clouds. For humans, rain means water and agriculture, but for the biosphere, it is rhythm, message, and memory. Next time rain falls on the sea, Imagine not just ripples, but countless invisible exchanges being set in motion. Each drop is a messenger of elements, a spark for photosynthesis, a signal for spores or plankton cells to awaken. Rain may seem ordinary, but in truth, it is extraordinary. It is both weather and alchemy, a silent force binding life across continents and oceans, carrying within it the chemical language of existence. Speaking of rain in the modern age is to speak of a paradox. Rain is both an ancient cycle that predates humanity and a contemporary phenomenon imprinted with the marks of our civilization. Nowhere is this duality more evident than in cities, where the chemistry of the sky has become entwined with the chemistry of human life below. As raindrops fall through polluted air, they change, becoming tiny repositories of technology, of industrial smoke, and even of daily habits. A single drop may contain nitrogen from car exhaust, sulfur from power plants, soot from burning fields, or traces of pesticides carried by the wind. Every urban rainfall, in a sense, is a collective diary written in water, recounting what society has released into the atmosphere. Scientists sometimes describe rain as the cleansing of the sky, but this cleansing is not always benign. During the Industrial Revolution, it carried sulfuric and nitric acids strong enough to corrode stone and exhaust forests. Today, in megacities, rain continues to serve as a solvent for the byproducts of civilization. It falls on concrete and glass, runs into rivers, seeps into soil, and redistributes the chemicals humanity has introduced into nature. The lesson here is both subtle and urgent. Rain is never neutral. It is chemistry in motion, an active agent of environmental change, rather than a passive backdrop. To understand rain is to understand the intimate entanglement between human behavior and the cycles of the planet. Yet within this scientific reality lies a profound resonance. Rain has always been more than molecules. It is experience, a presence that touches both body and imagination. The smell of earth after rain, called petra, is not merely poetic. It is oils from plants and compounds from soil bacteria released and dispersed into the air by falling drops. When people speak of freshness after rain, they are responding to a chemical truth, the meeting of sky, soil, and water, producing the fleeting fragrance of renewal. In this way, rain is both a scientific and emotional phenomenon, fusing what can be measured with what resists capture. Culturally, rain remains a mirror for human hope and fear. From ancient myths that saw rain as a gift or punishment of the gods, to modern times when satellites and meteorology explain its patterns, the spiritual weight of rain endures. An Indian farmer awaiting the monsoon, a family in California praying for relief from drought, or a Bangladeshi community preparing for floods, all are reliving a drama of hope and peril as old as civilization itself. Rain remains destiny. Its arrival or absence determines harvests, migration, economies, even political stability. Every rainfall is tied to the survival question humanity has carried in its heart for millennia. Will there be enough food, enough water, enough safety for the coming season? The paradox becomes sharper when we realize humanity has always sought to control rain. From the canals of ancient Mesopotamia to modern cloud seeding projects, we have never ceased hoping the sky might obey us. Yet these efforts reveal their limits. Cloud seeding may increase rainfall in some cases, but it cannot alter the monsoon, nor reverse drought driven by shifting climate. Technology can divert water once it falls, but it cannot fully decide when and how it will appear. Our powerlessness before rain, despite centuries of progress, is precisely what keeps it a symbol of awe. It reminds us that humans do not stand outside the natural cycle, but remain within it. At the same time, rain is not only a symbol of fragility, but also of connection. Modern science shows that rainfall in one place may be influenced by deforestation thousands of kilometers away, or by dust crossing oceans. The Amazon rainforest, for instance, generates immense rainfall through transpiration to the point of stabilizing climate far beyond South America. When trees are felled, rain vanishes not only locally, but also shifts global patterns. In this sense, each drop of rain is tied to decisions about land, energy, and industry across the planet. Rain is no longer just local weather, it has become a global dialogue, binding distant ecosystems into a shared fate. On this scale, rain is directly linked to climate change. A warmer atmosphere holds more water vapor, intensifying storms in some regions while depriving others. Droughts lengthen, floods grow more destructive, and rainfall becomes unpredictable. In East Africa, a failed rainy season may trigger famine. In Europe or North America, excessive rain can cause devastating floods. The chemistry of rain, its acidity, nutrients, pollutants, now combines with the physics of a changing climate to write a new story. Rain is both witness and agent in the Anthropocene. And despite such complexity, rain still offers the timeless intimacy it always has. A child holding out their hand, a poet gazing through a fogged window, a scientist collecting a sterile sample, all encounter the same substance, the same ancient cycle. To walk in the rain is to be reminded of continuity. Our ancestors once stood in fields with the same fears and joys, and future generations will too. Rain teaches humility, but also belonging. It affirms that humanity's story, no matter how advanced, is still written in water. Ultimately, the chemistry of rain is like a hidden language, translating human actions into planetary reactions. Acid rain tells the story of industrial smoke. Clean rain tells the story of environmental treaties. Today's rains speak of forests burned, emissions soaring, but also of recovery and repair. To listen to rain in science and in culture is to hear the earth respond. It is to realize that no drop falls alone. Each carries memory, consequence, and potential. And within that realization lies the greatest truth, that rain, whether blessing or warning, remains the most eloquent messenger between humanity and the planet we inhabit. Reflecting on rain is also confronting an eternal paradox, both familiar and wondrous. We often take for granted the rains falling by the window or the storms sweeping across the ocean, yet in every drop of rain lies the imprint of immense forces far beyond a human lifetime. Rain is not merely a weather phenomenon, it is the living thread connecting atmosphere, land, and sea, human memory, and ecological rhythm. The fall of rain is both ordinary and transcendent, a daily occurrence and at the same time a cosmic dance repeated for billions of years. Rain teaches us humility. No matter how advanced human technology becomes, we still depend on its rhythm. Drought can paralyze an entire economy, floods can wipe out villages, just one erratic rainy season can push a nation to the brink of famine. Satellites, sensors, and forecasting models extend our vision, but they do not grant us control. In rain, we see the limits of power, a reminder that Earth is not merely a backdrop for human ambition, but a balanced system upon which our survival is bound. We build dams, dig canals, divert rivers into fields, yet just one wayward season of rain is enough to undo countless plans. Rain reminds us that humility before nature is not weakness, but wisdom. At the same time, rain brings renewal. It is nature's way of erasing and rewriting. Dust is washed away, the air becomes clear, seeds awaken beneath the soil. Rain circulates nutrients through forests, rivers, and seas, ensuring that life's consumption is always replenished. Walking in the rain, we sense the promise of rebirth, a biological covenant etched into the very chemistry of water. Even after a century of industrial pollution, after acid rains once stripped forests bare and killed fish in lakes, ecosystems have recovered when humans reduced emissions. Rainwater, like humanity, can heal itself when given the chance. This renewal is both scientific and spiritual, a reminder that cycles of damage can also become cycles of healing. Culturally, rain is the canvas upon which humanity paints meaning. Poets praise it as sorrow, lovers call it closeness, farmers see it as hope, philosophers as renewal. Music and literature have taken the rhythm of rain as a heartbeat, at once lonely and connective. Modern cities measure rain in millimeters on charts, yet within homes, people still pause to listen to drops on roof tiles, still open windows to breathe the earthy scent of petrichor. Rain is both data and sensation, both graph and memory. It lives in imagination no less than in reservoirs. Perhaps that is why rain remains a metaphor that spans all cultures. It symbolizes beginnings and endings, grief and cleansing. It is a force that cannot be interpreted in one dimension because it contains contradiction. It nurtures and destroys, soothes and threatens, conceals and reveals. To think of rain is to think of life itself, with its fragility, its cycles, and its inevitability. We cannot separate the story of humanity from the story of rain, for the two have always been interwoven. From the earliest farming villages to skyscraping cities, people have always looked skyward, waiting for rain to fall. And the story of rain has never truly ended. As climate change disrupts the atmosphere, rain changes in unprecedented ways. Here, drought; there, torrential downpour; Ice melts, seas rise, and still the rain comes, but no longer as steady as before. The challenge of our age is to keep the old reverence for rain while taking on new responsibility. Just as our ancestors once danced to call the rain, we must now act together to protect the balance that keeps rain sustainable. Policy, technology, and global cooperation are the new rituals, our way of acknowledging dependence, even as we hold new powers in our hands. Ultimately, standing in the rain, we are reminded of our place in Earth's vast choreography. Every drop that touches us has touched soil, rivers, and seas, a part of a cycle older than humanity, now entrusted to our care. Rain is not just weather, it is a witness. It shows us that the planet is breathing, that cycles continue, that life exists not in spite of water, but because of it. To watch rain fall is to witness the oldest story of the universe being rewritten line by line, drop by drop. And to listen, truly listen, is to hear not only the voice of the sky, but the echo of a shared future, endlessly flowing from clouds to earth and back again.